In example 70C, we are required to express the complex number z squared over w in the form a plus ib. When we recall the concept that we have applied in the earlier parts of example 17, the real and imaginary part of a complex number, we notice that a being the real part of the complex number required, a is r cos theta and b will be r sin theta, since b is the imaginary part of the complex number. We think of these two forms for a and b because when we look at the question, all the information are given in modulus and arguments. So it is useful to think of the polar form and think of this concept. Thus, we will need to calculate the modulus of z squared over w, and we also need the argument of z squared over w given over here. With this in mind, we know how we will start off with the problem. First point, we know that modulus of z squared over w can be simplified to be mod of z squared over mod of w. Knowing that the modulus of z is 2, we have 2 squared here, and that gives us 4, which is this portion in our solution. In our solution is printed there, mod of z squared equals to mod of z, square it, that gives us 2 squared equals to 4. And we are given modulus of w as 4 as well. So for modulus of z squared over w, we will have the value of 1. Next, we need to work out the argument of z squared over w. Now, because argument of z1 over z2 equals to argument of z1 minus argument of z2, we know that argument of z squared over w will be equals to argument of z squared minus argument of w. With this in mind, we know that first we will need to work out the argument of z squared. But then again, recall that argument of z1 multiplied to z2 will be argument of z1 plus argument of z2. With these two concepts, we know that argument of z squared will be argument of z plus argument of z. So that is 2 times of argument of z. So it's 2 times of negative 3 pi over 4, which will simplify to negative 3 pi over 2. But keep in mind that for argument, we always code it within the principal argument range of between negative pi to pi. So for argument z squared, we will have to adjust until it's within this range. So how do we adjust? Over here, when we consider the Argand diagram, we know that negative 3 pi over 2 will be measured in this way, in the clockwise manner, until it reaches the positive part of the imaginary axis. So this angle is negative 3 pi over 2. In other words, z squared is somewhere on the positive imaginary axis. And this angle can be viewed as this one too, when we measure the argument in the anti-clockwise manner. And the argument will be pi over 2. So we know that the argument negative 3 power 2 is the same as the argument power 2. So argument of z squared is actually pi over 2. So knowing that modulus of z squared over w is 1 and argument of z squared over w z squared over w is argument of z squared minus argument of w, which should be pi over 2 minus argument of w, which is pi over 4. We get argument of z squared over w as pi over 4. So when we consider z squared over w and using the polar form, we have the result of cos power 4, 1 cos power 4 plus I times 1 sine power 4 as the imaginary part. So when we simplify this, we will have 1 over square root 2 plus I times 1 over square root 2, which will simplify when we rationalize to root 2 over 2 plus I root 2 over 2. Thank you for watching this video.